Physics Practical File. Experiment 1. Aim to determine resistivity of two wires by plotting a graph for potential difference versus current. An ammeter 0 to 3 ampere of range, a voltmeter 0 to 3 volt range, a rheostat, a one-way key, two wires of unknown resistance, battery eliminator, connecting wire, meter scale, and a screw gauge. So let's talk about the theory. First of all, we know Ohm's law. It is the fundamental law of electricity given by George Simon Ohm in 1828. It states that the current flowing through a conductor is directly proportional to the potential difference across its end, provided the physical conditions like temperature, pressure, etc. do not change. V is proportional to I. V is equal to IR and R is equal to V by I, where R is a constant of proportionality called resistance. A graph is plotted between V and I. This graph is linear and the slope gives the resistance of the current of the conductor. To find the resistivity, we use the expression ρ is equal to RA by L. Here is the diagram that we need to draw in the final exam, and we need to remember the emitter is in series and the voltmeter is in parallel with the wire or the resistance. Rheostat, and then the key and the battery. Then observation for ammeter and voltmeter. We need to find the least count for each, which is according to the thing or the device that you get. And here in the lab we have 0.1 ampere and 0.1 volt respectively. Then the length of the two wires is 21 and 42 centimeter. We don't need to remember the procedure, but if you want to, connect the plate as in the circuit and check the volt and meters 0 mark when the key is off and the least count. Check the highest and lowest value of the positions of the voltmeter and voltmeter by moving the rheostat knob. Start by sliding the rheostat knob from left to the right. Note the reading of the meter and voltmeter and take the odd numbers 5 or 7 of the observation and plot a graph between V and I, taking V along x-axis, y-axis and I along x-axis. Find the slope of the graph. Repeat the experiment and take about 3 readings at least. When we take 2 points A and B well apart on the graph, from A and B we draw two lines AC and BC parallel to the voltage. For Y1 AC is this and BC is this, and we need to divide both of these to get the R1 value and resistivity. Similarly for R2 we need to find the value and we need to draw the graph for both the wires here, which would come out to be linear, and you could draw these graphs according to your mind as well. And then the result, we need to remember the result and the precautions as well. Precautions contain the current should be passed for a short period of time and the connection should be neat and tight, and use low resistance rheostat. And we need to remember the source of errors. The end of the wire may not be clean, so we need to clean those. Connections may not be tight, and the VIN may not be constant due to excess heating due to the passage of current for a long time, or because of high resistivity of the rheostat as well. And we need to write this as well. Now experiment 2, to find the resistance of a wind wire using a meter bridge. So what is the apparatus required? We need a meter bridge, galvanometer, one-way key, a resistance, a Daniel cell, a jockey, a non-resistance, a screw gauge, and a sandpaper. So what is the theory for this? So principle of Wheatstone bridge is used in a meter bridge. A meter bridge is practically a Wheatstone bridge if there is no deflection in the galvanometer when B and D are at the same potentials. Bridge is balanced. Meter bridge has wire AC a meter long of magnet or constant stretched along a meter scale M, and it is of uniform area of cross section, so no need of resistance change along the wire. The wire whose resistance is to be found is connected on a series resistance box. from which an unknown resistance can be taken out, is connected across cap AD. A sensitive galvanometer followed by jockey is connected across BD, B and D, and so as to slide over via AB. So let's just remember this diagram. How do we create this? So the ends of A and C are connected with battery and key, and the middle is connected, the positive part is connected with the galvanometer, while the negative part is connected with the jockey. Then we connect a resistance box in it, and we connect the wire, one wire. Here we have drawn the diagram for parallel combination, but we need to draw the combination for parallel one, a normal single resistance one. Then we need to draw the observations value for the unknown resistance, where we will be using the resistance box for the known resistance, while balancing length is L and 100 minus L is here. We need to calculate the resistance by S is equal to, so S is equal to S by R is equal to 100 minus L divided by L. So by using this formula, we calculate the value of S. Just remember this by this is equal to this by this. Yes. Result, we need to find the result by giving the resistance of the given wire. And precaution is to maintain, to clean the connecting wires with sandpaper. Connection should be tight and neat, and we need to hold the jockey perpendicularly. Now sources of error is the screws of the instrument may be loose. The keys of the resistance box may not be clean. The wires may not be uniformly thick. Then we have experiment 3 to verify the law of combinations of resistance using a measure bridge. Similarly, we need all those requirements: a meter bridge, galvanometer, connecting wires, one-way key, and a resistance box, or dry cell, a cell, or a source of energy, a jockey, and two unknown resistance. And similarly, we are gonna use this formula. In series arrangement, the resistance are connected by end to end. The source of current is considered known between the free ends of the first and the last resistor. In this arrangement, the current passing through each resistance is same, so the voltage differs. So V is equal to V1 plus V2 plus V3, and I is common in all, so we cancel the I, so R series is equal to R1 plus R2 plus R3. Then procedure we do not need to remember, we need to remember this: S by R is equal to 100 minus L by this. So first of all, we will be taking one wire, calculating its resistance, similarly second wire, and then we need to connect both of these in a series. Here it's parallel, but we need to connect it in series, and then we need to find the resistance of that. And theoretically and practically, both of them need to be same, approximately same, and we get the answer. Therefore, the laws of resistance of combination of resistance is verified. Precaution again: neat and clean connections. The plugs in the resistance box must be tight, and we need to obtain a balance point between 40 centimeters and 60 centimeters, which means it should not be 100 minus L, should not exceed 60 centimeters, or should not decrease from 40 centimeter. Now, sources of error: the screws may not be tight or may be loose. The keys of the resistance may not be tight and clean. The wire may not be uniformly thick throughout. And we need to draw the unknown resistance R2 here, and we need to find the resistance over here as well for the series as well. And here we have taken about two readings for first two and 4 readings for the last, but instead of this, we could just take one reading for each and two readings for the series combination for the answer, which would be way easier. Now we come to experiment 4. To determine resistance of a galvanometer by half deflection method and to find its figure of merit. A galvanometer, first of all, what do we need? A galvanometer, voltmeter, battery, two resistance box, a rheostat of high resistance, one-way key, screw gauge, and connecting wires. A galvanometer is a device that is used to detect small electric current in a circuit. It is usually not used to measure current, but here the resistance of galvanometer can be found by using half deflection method. The key K is inserted and the deflection theta is determined with suitable value of R. I is equal to K theta, and here the total resistance would be R plus G. So R is the resistance of the, you could say, resistance box, and G is of galvanometer. So we could find E by R plus G. E is the voltage of the cell, and R by G is the total resistance, is equal to K theta, which is given by the formula I is equal to K theta. Then we need to adjust the shunt as well so that the deflection becomes theta, and then we get I is equal to E by R plus GS divided by G plus S, because these two resistance are actually connected in parallel, and we get the answer over here. We need to remember this diagram as well, and this diagram of as well, where this is figure of merit while this is the half deflection method. Then here is the formula and the values that we need to find actually. Then K theta by 2, and from here G is equal to R divided by R into S divided by R minus S, where R is very greater than S, so it's usually G is equal to R. Actually it should be R. The figure of merit K of galvanometer is defined as a current required for producing a deflection of one division, so it is measured in ampere. We could use this formula for measurement. So what is the procedure for resistance of galvanometer by the half deflection method? We need to plug in everything and introduce a deflection resistance of 5000 meter and insert the key. By adjusting the value of R so that the deflection of theta is maximum, we need to note that deflection, and we need to make sure that it is an even number. Now insert the key K2 back and adjust the value of S so that the deflection is half theta by 2, and we need to note the value of S as well. Here we have done resistance introduced, half deflection, and then we need to introduce the shunt resistance, and we need a theta by 2, where then we use the formula G is equal to RS divided by R minus S. Now for the figure of merit, we need number of cells and all. For figure of merit, take one cell, find its EMF with the help of voltmeter. Test the value of R to obtain deflection theta, and note the resistance and deflection, and change the value of R and note the deflection again. Then find the value of K using the equation K theta is equal to E by G, E divided by G plus R. Resistance. The value of G you could get from here, and the value of R is here, and theta is here, so if we get the K value from here. Now we need to remember the results as well, and precautions. Connection should be neat and clean, the resistance plug should be tied, and the high resistance from the resistance box should be introduced, or else small resistance can damage the galvanometer due to high voltage or high power. Then sources of error, that it might be loose, the screws might be loose, plug might be loose, galvano divisions may not be of the same size, and the EMF of battery may not be constant. Then it's experiment 5, which is to find the value of V for different values of V U in case of concave mirror to find its focal length. These two experiments are actually one of the largest ones, the last two ones. We're just left with about 24 pages, and these experiments are the crucial ones. So we need to find the focal length for this. So first of all, we need an optical bench with 3 uprights, a concave mirror holder, and 2 needles or knitting needles, and a half-meter scale. Then theory, we could use mirror formula over here to find the focal length, and we write the formula. And when a beam of light is parallel to the axis, it falls and it flicks back through the focus and forms an image which is diminished. We need to define that. Then we need to find, for the procedure, we need to find the rough value of focal length by focusing the image of a distant object on a wall, and mount the mirror on the mirror holder and place it upright on the zero of the optical bench or the desired location according to yourself. Then we need to level the optical bench and take the optical needle as an object needle O and mount it in the second upright, and the tip of the um, object needle and the pole should be on the same line or in between, which means the tip of the needle should be in the center of the mirror. Then we need to place the upright at a point which corresponds to the twice of the focal length of the mirror, and adjust the position of the pins until it coincides with the real inverted image made by the mirror. Then adjust the height of the pin until the parallax is removed as well. Then measure the distance between the pole and the object needle, and now move the image 2 centimeters from the center of curvature and place another needle between the object needle and the mirror. Call it the image needle. Now move the object needle 2 centimeters backward. Note the position of the three uprights. Now move the object needle 2 centimeters to the right of the center of curvature and place the image needle on the other side of the center of the curvature. Find the index direction of the object needle and back of the mirror and image needle and back of the concave mirror, and find the readings. So we need to remember the focal length, 1 by u, 1 by v, and uv graph, everything. And it is important to remember that in this case we just need to draw one of these graphs, either this one or this one. Yeah, so it's easier for us to draw this graph because we could remember that the center would pass from 30.5 to 20.5, and we could measure other values of this as well. Like this 22 would come across 29, and similarly 17, 18, 19, and 27, 28, 29, 30, and we could get the values actually. It's pretty easy over here. Instead of 1 by u and 1 by v, and we could hit the values of focal length using the formula as well. And yeah, you could use mine in it. So the precautions are that the upright should be vertical and the needle should be placed closer to the object needle should not be placed closer to the focal length of the mirror, and we need to keep our eyes at least 30 centimeters away from the image needle to view the image clearly, and parallax should be removed. Sources of error are the upright may not be vertical, or the parallax may not be perfectly aligned or removed. The scale on the graph may not be accurate. Yeah, these are the only few ones left right now. Then we would be done. 3, 4 left. Now we come across the convex lens by plotting the graph between u and v, and 1 by u and 1 by v. We could remember the u and v would be this graph, this one. Yeah, we need to remember this. And similarly for 1 by u and 1 by v, it is a similar procedure. You just need to remember this thing now, that we need to apply this formula, which is the lens formula. 1 by v is minus 1 by u is equal to 1 by f. Now procedure is we need to again find the rough focal length and mount the glass lens on the lens holder, place it upright on the position 50 centimeters from the bench, and we need to remember this diagram as well. Similarly, we need to remember this diagram for the lens as well. And after this, we need to remember, we could take about 3 readings from here. You could remember these readings or not. Now we need to mount it and put it in the middle. Then we need to level the optical bench in place. The optical needle on the sides of the lens and the position F into F and the image needle on the other side, using and finding the image. We need to remove the parallax between the image of object needle and image needle, and then we would be done. Now we need to note that the position of object needle, image needle and the lens upright. Then move the object needle 2 centimeters behind the 2F and remove the parallax and repeat the above steps accordingly. We could find the images and all. Then we need to find the correction to be applied to U and V, and the result would be in front. The precautions we need to remember that the object needle should not be placed closer to the rough focal length, and you could remember this. It's just similar that U and V for concave mirror was just the opposite image for this, and for this it's like this. Yeah, and then you could draw the points like it was 33, 31.5, I guess 30.5 for that. U and V it was 31.5 and 20.5, and similarly for this you could find a point in the middle, like it's 42.5 and 32.5. It was 31.5 and 20.5. Now it's 42.5 and 31.5, 32.5 and 42.5. That's easy now. You can find this as well. Now the precautions and other things: needles and upright focal length vertical should upright should be vertical, parallax should be removed. Similarly, these are the sources of errors. We don't need to remember one by V and one by U graph in here. It's not that important. Just one of them is good. Now next step is to determine the angle of minimum deviation of a given prism. Now we need to determine angle of minimum deviation for a given prism by plotting a graph between angle of incidence and angle of deviation. So we need a prism, first of all, a drawing board, pens and white paper. It's very easy. Theory, we need to remember that angle of refraction is equal to A, which is, you could remember here, A is this angle. Angle A is equal to angle R1 plus angle R2. This could be used, this could be found out using simple geometry, simple Pythagoras and all. A prism is a refractive medium bounded to intersecting plane surfaces that both disperses and deviates light. Angle R1 and angle R2 plus angle QOS. QOS is equal to 2 times angle S. 2 times angle S. This was, yeah. Also angle A plus angle QOS is equal to RT times angle S. So by angle from 1 and 2 we get that this and this cancels, and angle A is equal to angle R plus angle R2. And we know angle of deviation is equal to angle I plus E minus A, and refractive index is equal to sin I divided by sin R1. And when incident ray suffers minimum deviation, angle I is equal to angle E, and angle R1 and R2 are equal, which is equal to R. And here we could find incidence and deviation angle from here as well. And from the formula we knew that A is equal to 2 times R and R is equal to A by 2, and I is equal to deviation angle plus A divided by 2 using this formula. Yeah, angle I is equal to angle I here as well. So 2 times I minus A is equal to T. So T plus A divided by 2 is equal to angle I. Similarly, using this we could find sin I by sin R. sine I is equal to 2 times sine time is equal to mu is equal to sine times dm plus a divided by 2 divided by sine a by 2. It's very easy. Angle of minimum deviation and minimum value of angle of deviation we could find now. So using this we could find factor mu factor as well and result as well, which is this. First of all, we need to find this. We need to find the angle over here as well, and we need to define angle I, everything over here, and we need to put in the prism and everything, and we need to define the graph from dm and angle of incidence, angle of deviation and angle of incidence. We need to define an angle, so it's like Nike sign that's just reversed, Nike sign that's reversed. We could remember that, and the values would be 45 and 45. The minimum deviation angle would be 45. We need to remember that, and we could draw the whole thing then, the reverse Nike sign. Now the result is ID is a U-shaped indicating, ID graph is a U-shaped indicating that as the angle of incidence increases, angle of deviation first decreases and then increases. The angle of minimum deviation is 36 degree, and there is only one angle of incidence for which angle of deviation is minimum. The refractive index of the prism is mu, which is 1.486, and we need to remember the precautions that the incident angle should not be less than 30 degree and more than 60 degree, and the pins should be fixed well apart, and it should be vertical, and the prism should not change while performing the activity, and the pins that we pick should be thick and colorful so we distinguish between both of them, and the measurement of angle should not be wrong, and the pins are fixed. The pins should not be fixed very close to each other. We just left with 3 pages, which is this one activity is very difficult. It is to draw an angle between IV characteristic curve for a PN junction diode in forward and reverse bias. So for this, the diagram is very important. You need to remember all of this, this as well. This is the angle, this is the graph that is given in NCRT as well, so it's very important to remember everything in here. So experiment number 8, we need to draw IV characteristic curve for PN junction diode in forward and reverse bias. A PN junction diode is a PN junction diode, a 3-volt battery, a high resistance rheostat, 0 to 3 volt voltmeter, 1 millimeter ammeter, 1 milliammeter, a one-way key, and a connecting wire. So theory. PN junction diode is a semiconductor device obtained by putting in contact a p-type semiconductor with an n-type semiconductor. It can be biased on 2 different ways: forward biases, in which the p-type of the crystal is connected to the positive terminal while the n-type is connected to the negative terminal of the battery. The current increases as forward bias is increased, and reverse bias may with the p-type is connected to the negative terminal while the n-type is connected to the positive terminal, and a very small current is in flows due to the minority charge, so the resistance is pretty high. We need to remember the diagram where positive terminal is connected to positive and the negative terminal is connected to the negative, and here we need to remember the rheostat, how is it connected, and the key as well. And we need to remember the negative and positive terminals, and this is the N and this is the P type. And we need to remember that in our resistance, if you have seen the video for activity file for physics, I have explained that different colors of the diode. So the silver lining on the black diode shows the cathode region, which is the negative terminal for that, and of a PN diode. So yeah, here's the thing. It's this one. Okay, silver and this. So accordingly, this is connected to the positive terminal. So it's the negative one. So negative one is connected to this. N type is this. N type is connected to the reverse bias. Now we need to make the connections pretty precise, and we need to move it. And so like you might have the box actually that's present in it, and we need to make the readings accordingly. And it's very hard, I would say. It's very hard to make everything work, the precautions, everything we need to remember, and it's very hard actually. This experiment is actually very hard. So measuring should be for measuring, instrument must be a proper range, connection should be neat and clean and tight, and key used in the circuit open when the circuit is not used, and avoid applying forward bias voltage beyond breakdown. Sources of error: if the connection may not be tight, then the junction diode may be faulty. Yeah, we need to remember this diagram, the graph, which is the most important over here, and the values that we need to remember over here are very important. Thank you everyone for this video as well. Thank you.